Can I get your attention, please? We're going to go ahead and get started. We'll have some more time afterwards. Hopefully everyone got something to eat and drink. Let's see, JMK running in to grab his last bite, make it through Rich's talk here.
Wait till Rich starts talking.
Thank you for showing up. We're trying to kick off, trying to do these in person. I know it's been a long time that we've done these virtually, and people kind of got burned out from them. So now we're going to try to do some of these in person. Please, any feedback you guys have on things we can do better about this, and how we can arrange this to make it more convenient, try to get more people to attend. We'd love to hear it. So, do want to introduce Sean Dillon. He's the CTO of Steampunk. It's the Steampunk space, and he's just going to tell us a little bit about the space and the company that's hosting us tonight. So.
Thanks, Gene. So you guys already heard the least interesting thing you're going to hear tonight, which is who I am. So thanks for the intro. And just to give you guys a little bit of context about who Steampunk is, we're super excited about the business. We love coming to work now that we can every day. But just to tell you a little bit about who we are, we're not a new business from 3 years ago. We're kind of a rebranded business from 3 years ago. There was an acquisition of a long-time company. We're about 18 years old now. And the guy that acquired us was a guy by the name of Scott LaRose. He brought together a bunch of people who he had worked with in his career to restructure this company, former company, SE Solutions, into something new. And he said, look, let's make this the company that we all wish we grew up in, and kind of take all of our best practices that we learned over the years and put them into this. So that's who we are today. We had a couple of goals in mind. I think the first thing was we wanted to bring a little bit of that West Coast startup culture to the government's backyard, which you don't see a lot of in this area. I think you've probably all heard of the Beltway bandit mentality, and I've been working with the federal government almost my entire career, the 750 years I've been working. And we wanted to be the antithesis of that. So there's not only a little bit in the pink colors you see and in the fun name and Steampunk that you heard. I had to introduce that to our leadership team, which was an interesting and fun discussion. But we also wanted to build a place where people can have a career, not a contract. And people could have a long time journey and build a personal and professional brand in what they're doing, and not be here to send down to a customer site to never talk to anybody again, but get to work with a team of people and a community of people who we could learn from each other, who we could teach to each other. Not only do events like this in the community, but lean on people like Max and Gene and others in the business who I get to serve every day, just trying to have a good time in what we're doing, but also doing meaningful work for our customers. We do some really exciting stuff on DevSecOps. That's all a lot of fun. We're having a great time in what we're doing, but I will stop talking about the business. I will say softly, and I hated doing this at Meetups when I saw them, that we are always recruiting, but I'm not going to push because we want people who are interested in being a part of the fun thing, and that's what we've got. So with that, Rich, thanks for coming to us tonight. We're excited to talk. Gene, thanks for the intro, and I'll be around, guys. Thanks.
All right. So. All right. So speaking tonight, we have Rich Mills, who is currently at Amazon, but has been in Coveris and worked with some of us in the past, and he's going to be talking about DevOps and microservices. So cool. Take it away.
Thank you. So as Gene mentioned, my name is Rich Mills. I know at least a handful of you in the room. And for the rest, my name is Bob. No, seriously. So what I'm going to talk about today is what I call DevOps Engineering with containers to enable microservices. And the first thing you'll notice is it's a very buzzword compliant title. I try to get everybody to want to listen to it. So anyway, I figured I'd come up with a title for that. A little bit about me. Who am I? I'm kind of this. I guess I started out as a mad software developer. Came into my career doing a lot of C and C++ development, building software systems. But very early in my career, I had the opportunity to build software tools, right? So I got into a lot of the software tools, and I was more focused on how we build software than anything else. So I kind of turned into a mad software engineer. It was like, how are we going to engineer? We're going to build systems and get them out there and get people to use them. So I started turning into that. And then eventually, a lot of that stuff evolved, and it became, how do we build our software? How do we compile it? How do we install it? It became continuous integration, and then we're like, we built this cool software, how do we get it installed all the time? It became continuous delivery, and and then we called it DevOps, and we keep inventing all these terms. So, thank you industry for keeping inventing terms that describe what it is I like to do. So we have words to talk about that now. So that's great. A lot of what I'm going to talk about tonight, and the source of my experience, is I've spent the last dozen years or so, 2 decades almost now, working for various consulting companies. But I spent, as Gene mentioned, I spent a whole bunch of time working with Caveras for the last dozen years, and I got the opportunity to work with a lot of different customers, really trying to innovate and do different things, right, and try to help them build software better. And that's where a lot of this came from. So it was really about how do we accelerate the way that we build good software and get it out in the hands of our customers. So that's where all that came from. So, yes, sir.
When you say mad software developer, do you mean angry or crazy?
Mostly crazy. I'm really not a very angry guy, except for when people ask questions like that, man. So thanks.
Good to know.
No, so why am I here? So I'd like to share some of these experiences of really the journey that I've been on in, let's say, the last 5 years or a little more, working with customers that are trying to go from these huge monolithic systems into this utopia that everybody considers and thinks about. It's like, oh, we're going to do microservices, right? So I want to share a little bit of that with you guys, and show you some of what I would consider to be patterns for building these highly buzzword compliant systems that everybody was like, oh, we need microservices, and we need DevOps, and we need all this stuff, right? So I'll talk a little bit about what that really means and what it's meant for me, and we'll just share what it is. And while going through that, I can enumerate some of the problems that, quite frankly, I think microservices tend to amplify, right? We've always had problems building software, and when you have a monolith, you have a certain set of big problems. But when you go to microservices, you tend to have a different set of maybe smaller but more complicated problems. So I'll go through that a little bit. But hopefully this will give you a little bit of a reference of things that other people have done, that I have done, that you can walk away with. So even if you're kind of in this world of containers and microservices, let's give you some perspective on somewhere else maybe that it's been done. I'm not really here to convince you or to really explain to you what DevOps and Agile is. I'm going to assume everybody's kind of sort of heard of it at this point. I'm not here to tell you whether DevOps and Agile is the best way in the whole world to do things. Of course it is. No, anyway, it's just the latest way we kind of do things. And maybe I'll convince you that if you're not doing stuff in containers, maybe it is the future, or maybe it's actually kind of the present right now. So you may come away with that with my attitude a little bit. I tend to do everything fast, so I'm going to talk through a bunch of slides really fast, and then I'm going to go back, and then I'm going to go forward. So try and keep up. Anyway, so what are we going to cover? First thing I want to go over is a little bit about what I consider to be the pragmatic reality of shifting from a monolith or monolithic software design into microservices. What the kind of delivery process tends to look like for me, at least, when you're containerizing these services that you're trying to build. And then I'll talk about kind of 2 tech stacks. One is the operating tech stack and where you're kind of running all your software that you're trying to build. Then the other one really is what I call the DevOps platform tech stack. And that is like, where's all this tooling coming from that's enabling you to do that? And then the thing I always love to close out with is how teams and structure and organizations and the people that do all this stuff relates to that. Because, I'll tell you right now, my closing message is going to be, if you can't get your people to work together doing stuff, it's going to be hard to do no matter what. Anyway, so let's jump into it. Microservices. Is it kind of this utopia everybody's going with and looking for, or is it really just another nightmare that you run through? Yes, sir. Can I answer your question, sir?
Nightmare.
It's a little of both, as it turns out. So, if you're like everybody else, half your management went out and they read the interwebs over lunchtime and decided, you know what? We're going to take all our busted monolithic systems and we're going to split them up. It's going to be magnificent. It's going to be glorious, right? What we found, and we, the industry, the whatever, over the last, dozen years or so now, since the beginning of what we called service-oriented architecture, which is what, the 90s? Anyway, to do microservices successfully, it really requires this combination of solid technical architecture, how you're building your system, how you're designing it. Automation, which is, okay, I got all these pieces, how am I going to put them all together and make them work? Testing, I got all these pieces, how am I going to verify that they actually do what they're supposed to do? And then, quite frankly, development methodology that when I look at it, I see it as related very closely to what we refer to as Agile and DevOps Engineering, right? So, and without the right mix of these things, in general, stuff doesn't really go the way you planned. So as it turns out, it's a hard problem. So what do we do about it? So when we start talking about microservices, what I found is kind of non-ideal real-world microservices don't really look like the pictures that they draw in books and how everything is supposed to go. The reality is when you have a team that's come from a world of monolith software development, they tend to think in those terms, right? They tend to try to do the same things over and over again, right? So if you're lucky, you end up with a bunch of federated services, which is great. We've split something up, we federate them, they may do different things, and they talk to each other over a network. And so, but they tend to have these hidden dependencies. You took this monolith that was all coupled together, you split it up, and it turns out they're still kind of dependent on each other. They're just hidden now, right? It's not declared in a piece of code somewhere, they just stop working when the dependencies break, right? So a lot of these are independently changing applications, which is fantastic. That's what you want to be able to do with microservices. However, they're not really as loosely coupled as maybe we would have liked, right? And they're not as independent as we would like. So you end up with a lot of these services that are all wired together, and they need to be wired together. They need to be hooked together, and network connections and all this kind of fun stuff instead of just function indications and methods, in order to work properly. And now you've got a bunch of teams that are maintaining those services differently, right? And guess what? They don't talk to each other because they're off in their own little world. That's fantastic, right? But what they tend to do is they hide behind these APIs they build, and I've found that a lot of times these APIs they build really aren't that well defined, and they're certainly not very well documented. So it tends to be very difficult when things break, and you're like, I don't know what just broke, right? And they all have their freedom to move at their own pace, right? So you got all these teams going different directions, doing different things in different ways, which is fantastic. Sort of. And then you have this non-consistent tech stack, right? Because now they get all this freedom. They can use different languages, they can use different tools, technologies, all this great stuff to get the work done. So they have this freedom. But your desire with these microservices is that each of these guys should be able to deploy small changes once. Make a little change, deploy to production, off you go. Good, magic, right? Well, then what you find out is that you got all these versions going in all these different directions. You can't really figure out which versions work together. They aren't defined well enough that they're decoupled. So you can't figure this stuff out, even in test environments, much less get the confidence that you want. Don't ship this stuff to prod, right? So you end up with all these things changing at different rates, which vary between fast and network, quite frankly, and must be constantly built, deployed, and tested across potentially many different types of environments in many places, right? So that's what you end up with. And by the way, it's a lot like herding cats, quite frankly. And if you've never watched it, go look up on YouTube right now. You don't have to pay attention to it. The EDS commercial, I think they put it out in the Super Bowl in like 2009, of like these cowboys herding cats. It's the funniest thing. I was like, that's our life as software engineers. It's all herding cats. One of the things that comes out. Yes, sir.
So real world, you were just talking about previously. Would you still consider that a benefit over how your traditional legacy applications would be deployed? Meaning, if this is what it's going to end up with, is it worth our time? Have we really gained it?
Yeah, I think at this point there's no choice. We're going that way anyway. The whole world is going to more distributed, build out, smaller systems anyway. So whether you're taking a monolith and splitting it up into a little bunch of pieces, or you're trying to build something new and you're adding more pieces to it, you have this composition problem, right? Component-based software design and implementation, which has existed since, the 60s, is just gotten to a different scale and it looks different now. So you have this problem regardless. So is it the right way to go? I don't know, but it's the way we're going and the way we have been going for decades. So yeah, I think it's interesting. I think we're going to continue running into these problems. And it's going to say in another, let's look back in another 10 years and it's going to look a little bit different than it does now. But quite frankly, in the last 10 years, it hasn't changed radically. But what is changing radically is the technology underneath it. Right? And that's a little bit about what I'm talking about. So anytime you're talking about all this automation and pulling these pieces together, there's always this thing we're going to call a pipeline, right? And what I call a pipeline is basically, it's the definition of your delivery process, right? And we use that in a very vague way. But it's effectively, even without any of this stuff, if you have a piece of software, you write some code, you eventually got to build it, you got to test it, you got to install it somewhere, you got to run it, you got to put it in front of customers, right? That is a delivery process. It's how you deliver change, it's how you deliver software. Well, we tend to build these things we call pipelines now, and here's a scribbly example of one, perhaps, where in most cases, in all cases, your software delivery process, you're going to want automated through some kind of CI/CD pipeline, right? Continuous integration, continuous delivery. To be able to deliver your microservices, really get it installed, get it in front of people, get it built, get it tested, all that kind of stuff, right? And you're trying to get this into test environments, and eventually, of course, into your production environments, whatever that looks like. Well, a lot of times, the most important parts to me nowadays from modeling a pipeline is you have this kind of on the start side of it, you have this continuous integration phase, you have a continuous delivery phase, and then we'll call it continuous monitoring phase. But in the CI portion up front, this is really where, no matter what you're doing, you're taking your software, you're compiling it, you're running your initial set of tests before you install it somewhere, right? It's usually a bunch of unit tests, so you're compiling it, you're testing it, and you eventually figure out how you're going to package this thing up into an installable bunch of nuggets that you can put somewhere, right? And that all goes on there, and we have an opportunity to run all kinds of crazy tools to be able to do that, right? This is littered with tools. There's a million more tools out there. It doesn't matter what they are. The point is you're going to find these tools. And so this is your kind of initial, you're doing static analysis, you're analyzing the code, you're doing your initial testing of the code, unit testing, where you want to catch the smallest problems as early as possible, right? So you always have this CI phase, right? You got a bunch of tools to do that. And eventually you're going to publish some kind of thing, right? It's going to be a jar file, it's going to be a Docker container, it's going to be whatever it is, such that you can start saying, okay, I can take this thing, my package, my compiled piece of software, and I can install it. And that's kind of where we get into the continuous delivery phase, which is where am I going to put it, right? Well, I have to have servers or something, or maybe servers, but whatever. I have to have somewhere, so I got to provision some space to put it. I need some servers. I got to install the software. I got to configure it and wire it together with other pieces of software, so that I now have an opportunity, as it turns out, to test it again, because testing is going to happen over and over and over again, because that's just what we do, right? And if it passes my testing, I'm going to do a bunch of stuff, and I'm going to find more problems and more things, then I'm going to go back and fix it. But if it does well, then I'm going to start looking at promoting it, right? We start with a dev environment maybe, we do something called test environment, eventually a production environment, and that's great. So we do that. And then at the end, once it's going, you monitor it, right? That's kind of the next thing, which is you put monitoring in place and logging and metrics, because you want to make sure that that thing that you put somewhere that's running stays running and it keeps doing what it's supposed to do. And quite frankly, you still want to find the problems that you forgot that are in there that you didn't know about. Right? So that's why we have kind of monitoring. This is almost more continuous testing on the high side. We just make all the users do it. Anyway, so that's kind of your pipeline, right? And this is the core, really, of a lot of the automation that I talk about in the DevOps world, because it's impossible to talk about DevOps nowadays without talking about a lot of automation. So what does that mean? Well, let's put it in a little bit of context. So let's pretend this is a microservices application, right? This is loosely modeled after, some things I did with some customers at some point. Doesn't really matter what the little boxes are, but the point is, every one of these little boxes is a piece of software. It's a compiled, built, running application that it turns out is deployed independently, right? So not only is it deployed independently, but it's talking to each other all through network connections, right? So every one of these, out here I got some user interface type stuff, somewhere in here I got a bunch of services that interact with, then I got some back-end services back here that do more stuff, maybe have more users, I got some big data engine down here that's collecting all this stuff. But the thing to take away from this is every single one of these little services is either a custom-built piece of software, some third-party like Kafka in the middle, some third-party application that I install and configure, and I make it work my way. But all of this has to do with a lot of this orchestration, a lot of your kind of organization, right? So somehow I got to get all these stood up. Some of them are remote services where you got a bunch of containers and applications running here, but they have to connect to databases and Amazon S3 buckets and network load balancers and all kinds of other stuff, right? So I got all these things, and if you think about it, it's a lot of wiring. That's a lot of configuration. It's one of the things that we do as far as automation is how we do that. The other thing to keep in mind, by the way, is every single one of these could be based on a different technology stack. Some of it's built with Java, some of it's built with JavaScript, some of it's built with Golang, Go, whatever. It could be built with anything. So where do we go with that? Well, for every single one of those little boxes, you may end up with, you no longer have a monolith, which is just one giant Jenkins job somewhere that compiles everything. They each have their own little pipeline, right? So every single one of these services is going to go through a bunch of little steps. Well, remember I said in that pipeline where you get your CI stuff, you're compiling it, packaging it, eventually you deploy it somewhere, then you got to test it, right? So each of your independent services can, and quite frankly will, execute kind of sort of in parallel. They're all going to be asynchronously driven. You're not going to push, most likely you're not going to have one build per day that just builds everything, right? These are changing at different rate. You wouldn't even want to build everything because half of it probably doesn't change. Most of it doesn't change, right? So you're going to build all these things independently. But at some point, you kind of have to deploy them together. Because in many cases, remember, we're going from monolith to microservices. The point is, no matter what it is, you're most likely building some kind of enterprise product, right? It's a combined product that your company offers or your organization needs, which has a whole bunch of services working together, right? So at some point, you got to put them all together and make sure they actually work, right? And that'll probably be in test environments first. And you need to start thinking about things like, well, do I have one big environment that they put them all into? Or do I have a bunch of little environments where they put them all in separately, in different copies, right? So you're going to have to kind of choose. It's like, well, when service A and B go, do they go combined, or do they have their own little independent environments? So you got to choose that stuff. And I've done both, and there are advantages of both. But one of the things I will say, absolutely, this is where things like what I call dynamic environments become hugely important. So first takeaway is one of the things you want to be able to do is if I have one environment, I want to be able to very easily create another environment, right? I want things like infrastructure as code, configuration as code, and all these cool words so that it's very easy for me to stand up copies of these environments, right? And I'll talk more about this. This, by the way, is where I think the containers start to become a very natural fit for microservices, right? Because kind of summarize some of the things I said, but microservices typically vary in sometimes very fundamental ways, right? They're certainly owned by different teams, or in many cases they change at different rates. A lot of them are in fact built with different technologies. Could be different languages, could be different frameworks, could be different versions of the exact same languages and frameworks, right? And they often use different tooling for build and test. Right? So all of those pipelines could in fact be different. All of what they produce could be different. Right? When you're deploying and running these in shared environments, it also can be challenging, right? Because even just, as I mentioned, kind of different versions of shared dependencies. Anybody who's ever run a build server that has to be able to build, really old Java 8 or Java 6, or very modern Java 12 code, like having all of those tools installed together on the same build server to try to do things is hard to jump, right? So that's kind of a challenge, right? A lot of times they run on different operating systems, right? Some are running on Linux, some are running on Windows, some are running on different versions of Linux, right? Some are new Linux, some are old Linux, some are stuck in different versions, right? How many of us have old legacy things that are like, we're still running this old thing and we can't get away from it because reasons. A lot of times they have different resources and scaling needs. Right? So, if I have, this little app that only takes, half a gig of memory, and I have this other giant app that takes 12 gigs of memory at the same time, right? Scaling those differently have different requirements and ways to do that, right? So all of these things have to be kind of taken into account. This is where containers kind of come into play, in my mind, right? So one of the nice things, I'll talk about containers and more about what they are in a minute, but what's nice about containers and where they go is that it's kind of it's effectively a complete runnable server image. That you just say, run this thing. It's got everything on it that you need. Just boom, off it goes. I think I got bugs flying around. Right, so it's nice. It's all packaged together. It does everything you need to run. You can get individually kind of configured and quite frankly scalable instances, right? Nice thing about microservices, if I need 100 different web front ends and only 2 API servers, I can scale that way. right? But if I have them all kind of stacked together where I have a web server and an API server together and I need more of one, then do I have to replicate them together, right? So this is why we use things like containers to try to split that up, right? Containers, everyone will talk about, they're lightweight, easy to replicate. But the other thing that's really neat is that I'll talk about different ways we use containers. But they become really easy to run tool sets as well. Like if I'm running Maven, Gradle, NPM, different build systems, right? I can run each of those in their own little independent container and get exactly the version I need when I need it. So what do we mean by containers? How many people here are using containers, at least in some capacity? Does anybody not know what Docker is? Never used any containers? I'll just assume Jonathan. Since he is.
Yeah, it's me. What is it, Rich?
Yep. So anyway, one of the nice things about Docker anyway is, when you produce a Docker container, you have this thing called a container image, instead of perhaps some just standalone application. So in two worlds, right? If anybody came from the Java world, we used to compile and build jar files or war files, or basically just a compiled bundle of like Java classes, right? And then we had to install that on a bunch of stuff. In a Docker world, you don't produce a jar file necessarily in a way. You produce a fully runnable container where you just fire the thing on. So what does that mean? Well, with traditional VMs, we have to run, of course, a full operating system, right? So somewhere on the bottom, you have some server and it's running some version of the operating system. Maybe it's Linux, whatever it is. And maybe this is your Amazon or your Google provider has all this stuff. And then on top of it, we run a full-blown guest OS, so we boot Ubuntu or something like that, right? So we boot a full version of Linux. And we run a bunch of binaries and libraries on top of it. And then finally, eventually, I put my application on top of that giant stack of stuff. And then if I want another version of the same app, I load up the exact copy of everything else, and then I have one little different thing on top, and then finally the same with different applications. On the Docker world, maybe a bunch of people see this. What it basically does is it squishes everything down. So it reduces all this duplication of the giant guest OS down to an isolated container, right? So they all share this kind of guest OS at the bottom. And then it just has a library of components on top of it. So your container tends to be this squished down thing where you get a lot smaller versions of it, and this really is with Docker. And the nice thing about it is Docker basically, a container, captures all the specific runtime libraries you need. So every one of these containers basically has the core stuff that the operating system needs at the bottom, which tends to be just a very stripped down version of stuff. Then maybe it has the specific version of Java you need. It's got the libraries that Java needs on top of that, and more libraries, and eventually maybe a whittled down version of the Tomcat server, and then finally you have your code that you put on top of it, right? So it kind of squishes this all together. So instead of me having to go install a version of the OS and then install a bunch of middleware stuff on top of it, I basically just say Docker run boom my service, right? And it throws up an entire container that has this whole stack in, and off it goes, right? So if I have a million different versions of this stack, it's very easy for me to run them all at the same time. So where does that go for us? Where do we actually use these things we call containers? Well, there are two ways I think about using containers. One is how to use them as kind of your tools and infrastructure, and the second is how do you produce your software in it. So we'll talk about the first one first, right? Containers as tools, right? So one of the big things that I've found huge advantage in is build infrastructure. So if I run Jenkins, let's say. So I run Jenkins, and I have these Jenkins agents, right? And the agents are just the workers. They do all the work. They compile everything, they assemble everything, they run all my tests, they do everything, right? Well, being able to deploy Jenkins into a container orchestrated environment and just launch more containers anytime I need to adds so much flexibility because I can get the exact versions of software I need. I don't have to have some virtual machine with 9 different versions of Java and 12 versions of Maven installed on it all at the same time, right? I just run Docker containers that have each of those on it and pull that in, right? So having them as Jenkins build agents makes it very easy to scale capacity as I need, and then I can get all the tools I need, whatever they need. The other neat thing about that is that the developers can then, on their desktop, run the exact same container. So they can run exactly the version of Maven, or Gradle, or NPM, or whatever it is. in the exact same way that the Jenkins server is going to run it. So I can run those all. The other thing that I've started doing is I build effectively what I'll call runners, right? So if we're using Ansible or Helm as another tool or something else, right? I will build a specific runner that knows exactly, none of this, oh, well, gee, I gotta run Ansible or I gotta run Chef or some of my deployment guys have to be able to run this. They have the wrong version installed on their machine, or they have to configure all these plugins and also like crap to make it work. I can basically build a single Docker container that has the exact version of Ansible and the exact plugins and all the other crap that it needs to actually just fire it off and run it. So now all my developers can run it in the exact same way. Nobody's deploying to production with the wrong version of the software. Right? So I find that to be hugely advantageous. And then finally, containers as infrastructure, right? Which is a lot of times we're going to run, monitoring, logging infrastructure. Like how am I collecting my logs? Where am I getting my monitoring? Right? We run those basically as Docker and deploy them into Kubernetes. And then finally, stuff like security services. Like you can run all your authentication, auditing, all your kind of central scanning tools. They all just naturally ship as containers nowadays, which makes them very natural to build and run in this form. And then a lot of your testing infrastructure as well, which is it's really easy to fire up Selenium servers or whatever you need to do as Docker containers and whatnot. But of course, where we go with that is, sure, those are all tools that other people build and I just run and configure. But we eventually get to the point where, well, we're building microservices. How do we do that, right? So containers, right? So containers is kind of your deployment platform, how you're building it, how you're running, how you're shipping stuff out, right? And you have choices of all containers versus hybrid. What's nice about going in the Docker world is if you've got these kind of federated services, then you can run some as Docker containers, some as kind of your traditional architecture. So what does that mean? So when you're starting to talk about running it as your kind of core platform, so let's talk about your operating infrastructure, right? So anytime you start getting these large groups of microservices, which may be containers, maybe not, but let's assume they're containers, across a lot of test environments, you end up with a lot of this kind of complex configuration. Kubernetes is a system that I've been using for 4 or 5 years now, I guess, which is this highly scalable, self-healing, cost-efficient platform that really is just a really cool way to deploy a lot of containers and wire them together. So we use Kubernetes a lot for the last few projects I've done. And it effectively enables you to build and deploy these complex enterprise-scale systems in flexible configuration. And Kubernetes is cool because it's self-healing, it's easily scalable, it makes it easy to kind of just naturally build highly available, kind of scalable applications. And managing these applications on top of this, to do it well though, requires, as it turns out, a lot of kind of tooling infrastructure. So when we build Kubernetes clusters, right? So effectively what it is a cluster in Kubernetes term is really just a bunch of nodes underneath. So the way we build it is a bunch of Amazon EC2 nodes, a bunch of your traditional VMs. You install Kubernetes on it, and Kubernetes just kind of glues them together, and you don't really know what's a node. You don't care anymore, right? Because you just deploy containers into it. And we group them as different tiers. So we have like a web tier, and an app tier, and a database tier, and that's all fine. Doesn't really matter. But in order to do that well, somehow you got to install all these things. You got to get all this stuff put on top of it. And then to do anything well, you need certain things, like you need different roles in your cluster, you need storage mechanisms, you need all this stuff so that this scaling stuff happens, right? So you got to manage that stuff. Then on top of it, you're like, oh, well, I need logging tools. How am I going to do that? Well, maybe it's Elasticsearch and Grafana. Maybe it's something else. I need monitoring tools like Grafana, Prometheus, all these tools that are out there. You need something to collect metrics, monitor how your software is going to run. At some point you need networking levels. You need Nginx for like controllers for all the web interfaces. There's all this stuff basically that goes on top of it, right? You need some way to orchestrate that. And one of the things that we found is initially we use a tool called COPS. It's Kubernetes operations. And it basically helps us install this. We wired that all together with some Ansible. Helm is a packaging tool for Kubernetes packages. So we use, as it turns out, a complicated set of stuff, right, to build this up, just so I could deploy one container. Okay. If I was only going to deploy one container, I would use Crack. But if I'm going to deploy 3,000 containers, which was pretty typical for one of our clusters, this is where you start building stuff. And as you can imagine, there's a little engineering work because what's nice is once you get this stuff, then I can use that for my DevOps tool stack as well, right? So suddenly, I can install Jenkins on top of it, let's say, as a CI server. And I can start firing up different containers on it, builds, and all that wonderful stuff I was talking about earlier, right? I can put SonarQube and Nexus and all the other tools that I need to build and assemble my software. And it just basically fits right on top of this. I can integrate it with external services, I can run some mixed VM services, so I can do all kinds of stuff. Right? So in our case, we were using typical modern tools at this point. Jenkins, Nexus, Harbor was another artifact repository, so a lot of stuff. Right? We just layered on top of it, boom, off we go. Well, the other thing, same basic cluster architecture underneath. Remember that little microservices app I was talking about earlier? Well, again, I just start deploying these things on top of it. And I can wire them together, I can create different environments that all run on top of one or more clusters. And it becomes very easy to kind of duplicate these test environments because when you deploy things on something like Kubernetes, it's really just a bunch of YAML definitions that talk about, I have these services, they connect this way. You just copy a bunch of YAML, and boom, off you go again, right? We have multiple. Of course, copying and pasting is not the best solution in the world. And there's, of course, engineering mechanisms of how you do that to minimize and separate your kind of instance configuration from. So what does that really come down to? How do you do that all well? And that's kind of what I was hinting at, is we use things, so Helm is a tool in Kubernetes that basically allows you to kind of package a template of, I need a web server, an app server, a database server, and I will tell you later exactly how many of those or whatever, right? So it's a packaging mechanism that you can use to package a group of things together in Kubernetes. You use templates for deployment. It's basically, it allows you to define these templates for all that crazy YAML that I was talking about that define these things, right? So we used Helm a lot for this, and it was very successful. So it helped us manage kind of like the thousands of lines of YAML that it took to deploy one application, and then I could deploy that same application or that application suite 30 times by having a very short definition file that's 15 lines of YAML that just defines a few settings. What are the database settings? What are the other configurations? And that's what Helm did for us. It was extremely helpful in doing that. Because those values kind of at runtime are what define how one application environment is different from another. So that kind of comes into play, right? The other thing we did very successfully is all of those manifests, of course, were stored in Git, as source control. But even the value definitions, right? So those things that define the different environments, although a much smaller set of things that were unique, we also stored that in Git, right? So when we were able to basically fetch those based on a Git SHA version of like, okay, this is the exact version of something I want, and off we go. And there's the configuration settings, and we even set up. We kind of followed in this case, for anybody that's heard of it, kind of a GitOps workflow where we would just check something into Git, something would be watching the Git environment, or sorry, the Git repository, and it would just basically say, oh, you want to make changes. It would fire up automated pipelines. In this case, we were using a tool called Tecton, and that would basically deploy all our new stuff and boom, magic. So that was all, right? The other kind of neat user service thing that we did is we actually built some very simple Jenkins jobs that all the testers and developers could go to. And they basically go to Jenkins, they would push a button, and it would effectively just launch, basically, it would fire up a new test environment for them, and suddenly they could put whatever version of code they wanted there, do some kind of ad hoc exploratory testing before they merge their changes over to the main line and move on. That, as it turns out, was a huge benefit. It was heavily used. I think of all of the jobs in our Jenkins environment, that job was run more times in a single day than everybody else. Because one of the things we did with it is we would let them launch an environment, but it would burn out 8 hours later. So they would get it for the workday, and then at the end of the day, we would destroy the environment, right? And one of the neat facts about that is that, you've heard this maybe cattle versus pets thing. It kept people from trying to hang on to these golden test environments that had golden data and all this kind of crazy configuration in it. because they knew it was going to be destroyed at the end of the day, and they would be forced to rebuild it, which forced them to put more stuff as infrastructure as code and forced more automation. And it was kind of this nice self-fulfilling prophecy by giving them the ability to do that.
That sounds awesome. The guys that figured out how to do that must be the smartest people ever.
Yeah, some of them. Some of them are still kind of jerks, though.
Like the only real benefits.
There are some people in this room that actually helped build a lot of that stuff.
Well, we got most of the way there.
Right.
Well, a percentage.
Right. You know, 90% there is definitely done, right?
Still waiting on my Android.
So what this kind of allowed us to do, by the way, is because all of this was managed through code, it made it really easy to manage multiple clusters, right? So this heavy use of kind of infrastructure as code and automation enabled us to replicate things in as many ways as we wanted to go, right? All the DevOps kind of shared services kind of sat in the middle, same cluster architecture, but we set them all there, like Jenkins and the artifact storage. But the rest of the clusters, you know, we had our giant QA cluster, right? That's where all development and testing. And this was a cluster that would scale, you know, on the weekends it would scale down to maybe 60 nodes, so there would only be a few nodes, and then the developers would show up Monday morning, and boom, they would be pushing buttons and doing everything, and it would scale up to about 200 nodes, right? So a lot of this, and just think about it, by scaling down over the weekend, that was 120 nodes that I'm not paying Amazon for, right? Because they charge by the minute. And
They're
a lot of money.
outrageous.
What's that?
They're outrageous.
I think they're very
Outrageous.
reasonable.
Yeah, it's really reasonable. Yeah, you should just see what Amazon spends inside. But anyway, so the scaling aspect allowed us to do it. We would have a QA cluster, and that was always under churn and everything. And then we had a staging cluster and a production cluster, and there was actually another production cluster. But it made it very easy for us to replicate this. We even had what we called our dev-cated desk cluster, where every Friday we would burn the thing down, and then we would relaunch the cluster from automation just to make sure we could. And this is where we did all of our automation changes that we would prove they work, and then we would start rolling them out through the changes, right? So a lot of this kind of infrastructure as code allows us to roll out these changes, which ended up being a very good thing. But what that comes down to is, as you can imagine, there were a lot of different people doing a lot of different things, right? Just think back to that picture of the microservices application and imagine every single one of those boxes being owned by a different team, a different person. Imagine all the infrastructure that's there being owned by a platform team, right? So a lot of changes in a lot of different ways. And, you know, with all of these clusters, you know, if we on the platform team rolled out something that started querying other clusters, as you can imagine, you know, has a big impact on it, right? So how do we do that? Well, it really comes down to, it's kind of Conway's law, if anybody's heard of it, but your teams have to align really to your delivery process in my mind, which is how exactly is it that you're producing the software? Who's writing the software? How's it getting built? How's it getting assembled? Where is it going to run? How's it going to live? How's it going to get up? Okay? If you can't answer those questions, the chances of you building an actual working process to automate that is very small, right? You're always going to have problems, right? So you got to figure out how your teams are going to align with the delivery process, and they go hand in hand, right? Your delivery process is going to be defined by your teams, right? A lot of times your teams are going to be part of a shared product. You all work for the same company, you're all on the same project, you're all on the same something, right? And you probably work together, right? And if not, congratulations. You are a mini startup, rock on, do whatever you want. Go crazy, right? But if you are part of a bigger team, don't pretend that you're not. Communication is important. Like how those teams collaborate, how they share skills, how they share standards is going to be important, right? Dev and QA team members are going to need to learn new technologies, right? As you go into this space, right? If the only people that understand Kubernetes is your platform engineering team, you are not going to succeed, right? Your developers have to understand, oh, well, this is what a YAML file looks like to deploy my pod and my containers and how I replicate and how I scale them, right? They own their applications, right? You know, you can't just make, oh, it's the DevOps team call. As soon as you say you have a DevOps team, you've started down the wrong path, right? The DevOps team is everybody. We're the team. We just happen to have some people that have some specialty and things that point at them. They say, oh, it's a DevOps problem. It's not a DevOps problem. It's our problem. We have to solve it, right? And as independent as anything is going to be, you're very likely to have certainly some shared patterns. Like even look at those clusters, right? Those were the same things many times, right? There's going to be different standardized ways to do it, where you want to give people independent freedom to go, you know what? It's microservices. Use whatever language you want to work, right? But in the end, they all got to come together somehow. And if everybody's using Java, don't invent 32 different ways to build Java applications. You're just wasting your time, right? So you kind of want to figure out how to get it all together. One of the ways I've gravitated to over the last number of years is kind of what I call horizontal technical guilds. But somewhere you're going to have a group of specialized professionals working together to solve cross-team problems. So for example, you are going to have test engineering expertise, right? You're going to have testing expertise. You're going to have DevOps, what we call DevOps expertise, but really kind of platform and automation expertise and build system expertise, right? You are going to have security expertise. You are quite frankly going to have developer expertise and business. You're going to have all different kind of these horizontal kind of names and stuff. And what I find is that, you know, if we take a look at this testing, let's say, you know, testing, I'm going to call this kind of a guild member, right? This is a horizontal team. But you're going to have guild members who are in team, who are focused on team-specific problems, which is their job is to build whatever component these guys are building, right? And their job is to solve that, right? You're the tester, well, you're the test expert. You're supposed to help everybody get their stuff tested, right? You're the DevOps expert. You're supposed to help everybody get their stuff assembled and deployed and run, right? You're the security guy, et cetera, et cetera, et cetera, right? So they're focused on their vertical problem. However, what you want to do is eventually get some centralized people, which is, well, if you've got a whole bunch of teams, well, they're going to need some test engineering support out in the middle somewhere. Somebody who knows how to run SonarQube and Selenium, and basically, these are the kind of consultative group of people who are providing expertise across all the teams, right? And somewhere you're going to have a lead to kind of organize and kind of keep that together, right? Because that guild kind of establishes what I call the cross-team standards, right? You know, what are the standard ways we do it? How are we going to get shared success instead of a bunch of cats running in a million different directions? Right? So it really becomes what I call a cross-team function, right? It's a function across the teams, as opposed to a cross-functional team. So now, certainly one of your challenges you're going to find is pick each one. You're never going to have enough security engineers to put on everybody's team, right? Quite frankly, you're probably not going to have enough DevOps engineers to put on everybody's team, and you may not have enough test engineers to put on everybody's team. So you got to solve that problem too. Excellent.
So if you're trying to standardize across teams, like I totally get the, you know, having like center of excellence for testing, for DevOps, for security. Why wouldn't you want to do the same thing for development?
You do. I'm not saying you don't. I think it's actually more common in places I've seen that have like software architecture centralized, right? And your design standards and all that stuff. It's very common sometimes to have that. I'm saying you got to make sure you do it there too. So you're absolutely correct. This could be brought out for every single vertical. The slide used to have just DevOps people because those were the important ones. But then I realized, oh well, yeah, there's kind of testing and there's kind of security, and yeah, you're totally right. There's developers and everything else as well.
Pretty soon just big.
Yeah, it's a big square. We're all just living in the matrix. So, anyway, my key takeaways here, right? Remember, your pipeline is going to implement whatever your delivery model is, and it's going to be a function of your organization. It's going to be a function of your software, right? And it's what is going to enable your teams to progress both independently and, quite frankly, together. Right? I found that containers provide a very neatly packaged, independently kind of way of building deployable units that can live next to each other. Microservices tend to require a lot of orchestration. You know, everything you're trying to do here, a lot of automation, a lot of orchestration, a lot of bringing stuff together to be able to deploy and configure it. I've certainly learned over time that when you do this well, you get stuff like dynamic environments, which are an amazing enabler to allow your developers really to test something in a very production-like manner. In order, again, to do this, everything has to be stored as code. Infrastructure is code, configuration is code, pipeline is code, deployment is code, everything is code, right? It all goes into version control. And then finally, your teams are going to need new skills. it's new stuff, right? They can't just sit around and pretend everything's a black box. They've got to understand what's in it. So, and don't forget, you're all on the same team. Work together. And that's all I got.
Thank you very much.
You are welcome.
Just a quick wrap up here. Still some food in the kitchen. Plenty of cookies left. You haven't gotten them. We are going to try to pick these up and do more in person. So I'm definitely looking for people willing to speak. People, if you know people that want to speak, if you want to speak, please reach out to me. Give me some ideas. Even if you just have topics you'd like to hear, please feel free to reach out and tell me, hey, can you find someone that wants to talk about this? This is something I really want to learn, right? If you have any feedback on the way this went or things you'd like to see, please feel free to let us know. We're looking for feedback, and please tell your friends, coworkers. We'd love to have some more people out here. So thank you very much, and thanks again to Rich.
Thank you.
And thanks to Steampunk for letting us host here. So.